Hello, Andrew, back again here for a brief video on Archimedes Principle. So, hello there, GCSE students or whatever you're studying, and welcome back to our channel. Today we're diving into the fascinating world of physics, as we tend to do here, to explore one of the fundamental principles that governs buoyancy, Archimedes Principle. So, if you need to get some notebooks or whatever, grab those so we can dive right in. But let's start by talking about Archimedes himself. I got a little picture of there. Archimedes' principle is named after the ancient Greek mathematician Archimedes, who made significant contributions to the field of physics. This principle helps us understand why objects float or sink in fluids like water. But before we get into that, let's understand what buoyancy is. Let's do that first. So, buoyancy, and I'll get my little pen here so we can scribble things in. Buoyancy, which is labeled by the F subscript B on these free body diagrams and these sketches of the swimmer here, is an upward force exerted by a fluid, such as water, on an object placed in it. And this force opposes the weight of the object. So we can see here I've got the weight of the object and I've got the buoyancy. When an object is placed into water, it displaces some water equal to its own volume. That's what Archimedes discovered. He made this note when he was, the story is when he got in the bathtub, he realized that the water displaced upwards, and that displacement was equal in volume to the volume of his body that it displaced the water, right? When an object's placed in water or an object's placed in a fluid, it displaces water or that fluid equal to its own volume, right? So that's the cool part. Archimedes' principle states that the buoyant force acting on the object is equal to the weight of the fluid it displaced, right? So here I've got the man's weight. The man has displaced an amount of water which is equal to the volume of him, and he has a buoyant force acting upwards which is equal to the weight of the water he displaced. Now, of course, that water is not, his volume in water is of a much lower weight than him, so we can see that on the free body diagram. I've got a smaller buoyant force than I do for his weight. So if we're just thinking about, the buoyancy there and his weight, there's going to be an overall resultant force in the down direction, and he's going to sink, right? So let's keep kind of going through the key points here. So in simpler terms, if the buoyant force is acting on an object is greater than its weight, the object will float. If a buoyant force is less than its weight, the object will sink, like our example here. And if they're equal, the object will remain suspended at that particular depth. So that's kind of the idea of hot air balloons as well, right? When hot air balloons are maintaining an altitude, that's because the upthrust that they have is equal to the weight downwards. Same sort of principle here, right? If my force and my buoyant force, and my weight are equal, I'm going to stay at that same level because I'm going to have an overall resultant force of 0 there when I add up the y-axes. So let's take a look at some other examples to hopefully make this a little bit more clearer for you. Think of a boat floating in the water like I've got here. The boat displaces a certain amount of water, and according to Archimedes' principle, the weight of the water displaced by the boat is equal to the weight of the boat itself. That's why the boat floats, right? In this case, we've got specific numbers. The weight of the boat is 40,000 newtons and is displaced enough water of weight 40,000 newtons to maintain that overall 0 resultant force in the y, so we're floating. So to sum it up, Archimedes' principle helps us understand why objects float or sink in fluids by comparing the weight of the object to the weight of the fluid it displaces. Pretty neat, and I hope this video helped explain and helped you grasp the concept of Archimedes' principle. If you have any questions, feel free to leave them in the comments below as usual, or any suggestions or any requests or anything like that. Don't forget to like, share, and subscribe for more educational content. That helps me out. and happy studying. If I've finished talking about physics now, so if you want to get yourself away, that's fine. If you want to hear more about me and the channel, you can stick around till the end just now, but no obligation. So I'd like to thank everyone as usual for your interest in physics, for your interest in me discussing physics. Your support means a lot. My intention with this channel is to educate and especially help out those doing high school classes with their physics. And as I said in the last, in a few minutes ago, if you have any sort of requests or suggestions, just drop them and I will do my best to help you out, because that's the whole point of this thing here. I've got a bunch of links here to other places you can find me. I've got my link tree, the YouTube you're already on. I've got resources, free and paid resources on my TED storefront. There's a link there. All these links are also in the description. The Twitter, the Instagram. If you're feeling especially generous and you want to buy me a coffee, I've got the coffee page there, and I will drink that cup of joe with a lot of joy. But until next time, I'll see you all later. Bye, bye, bye.